Do you feel the vibes?
So we already know that, cosecant and sine are related because sine, cosecant is 1 over sine, secant is 1 over cosine, and so on, right? Cotangent is 1 over tangent, right? And so we can also go the other way, right? Sine is 1 over cosine and so on and so forth. Now, one other thing, right? So let's take a look at this. If we have a triangle like this, okay, so this is theta, this is 3, 4, and 5, right? This is a 3, 4, 5 triangle. The sine of this, sine of theta, we all know is 3 over 5. Cosine of theta, we all know is 4 over 5, right? Now, tangent of theta is 3 over 4, right? This we know. We've been doing this since last semester, chapter. So now, why don't I try to do sine theta over cosine theta equals, let me just write the tangent over here. Right? So now this is equal to, sine of theta is 3 over 5. Cosine of theta is 4 over 5. This is equal to 3 over 5 times 5 over 4. Right? Which is equal to 3 over 4, which is exactly what we said tangent was supposed to be. Right? So another way to find tangent then is by doing sine over cosine, right? So that's another thing. Tangent is sine over cosine. We know that from a different way, right? We know that from a different thing because on the unit circle, where this is 1, we said this was sine theta. We said this was cosine theta. And tangent, right, was the vertical over the horizontal. So it was always sine over cosine, right? Sine over cosine. So that's another thing that we already know. And now we're just writing it down more formally. Okay. So back on this unit circle, right? This is a right triangle. And I know that for a right triangle, you have x and you have y. And x squared plus y squared is equal to 1, right? So here, well, this is actually reversed, but what are x and y here? One is sine and one is cosine, correct? X and y, look, one is cosine, one is sine. So I could do, sine plus cosine or cosine plus sine, it's the same. So if I'm going to do x squared plus y squared, that's the vertical squared plus the horizontal squared. So that is sine of theta squared plus cosine of theta squared. Yes? Now, another way to write this, because we really don't need parentheses, is this. Sine squared theta plus cosine squared theta is equal to 1. So this is the Pythagorean theorem. And then from that, we get this with the sine and cosine, and this is called the Pythagorean identity. Okay, so let's talk about this word identity. In math, a trigonometric identity is when you have two things involving trig, right? Trig functions that are equal to each other. And then if you say one is equal to the other, that becomes a trigonometric identity. So we always knew cosecant is 1 over sine, but when we write it like this, it becomes a trigonometric identity. Okay, here. Now, look at this one. Okay. Now, one other thing. If you want to say sine theta squared.
Here's what I found.
Oh, what did you find? Oh, okay. So if you want to say sine theta squared, the only way to say it is sine squared theta. If you say sine theta squared, that is a different thing entirely. Okay? So let's talk about what those are, right? Suppose you have an angle 30 degrees. Okay? What's sine of 30 degrees? What do you guys think? Ooh. What's sine of 30 degrees? 1/2. From last chapter, sine of 30 degrees is 1/2. Okay? Okay, so now, suppose I wanted to square this. Okay? That would be the same as sine squared 30. That would be 1/2 squared. So that would be 1/4. So that's sine squared, right? It's 1/2 squared. Now, if I mistakenly, okay, so I have sine of 30 is 1/2. If I write it like this, that becomes sine of 900, which is not what I'm talking about, right? So do you see the difference? It really makes a difference when you put that square. Okay, now, so we have our Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. So I'm just going to write it here. Now, just for fun, let's multiply everything here by cosine squared theta. Okay? Now, sine divided by cosine was what? Tangent. Sine squared divided by cosine squared is tangent squared. What's cosine squared over cosine squared? 1 equals 1 over cosine we know is secant. 1 over cosine squared is secant squared theta. All right? So what do you see now? I have another identity, this one. Okay? So now, suppose I take sine squared theta plus cosine squared theta equals 1. Divide by, let's divide by sine squared this time, just because we can, right? Okay. Now, what's sine squared over sine squared? 1. What's cosine over sine? Cotangent. So this is cotangent squared theta is equal to 1 over sine is cosecant squared theta. And you see this one is the other trigonometric identity, right? So we have one main trigonometric identity, okay? And then that one has two friends, right? So all of these, okay, these trigonometric identities are the VIPs of the trigonometric world. Everybody needs to know the first one. You have to know the first one. The other two, it's good to memorize, but you know I don't like memorizing. You can always derive them so you know where the 1 and the squared and everything goes. Okay? If you know where they come from, then you can figure that out. Okay, so these are, very important identities. Okay, now, so we have solved a problem like this before, right? Given cosine theta is equal to -1/2, find the exact value of sine of theta. So we did this before. What we would do is we would draw a triangle, find the missing side, and then find all these other angles. Great. In this chapter, we're learning about identities. So we're going to do these using trigonometric identities only, no triangles. Okay? All right. So take a look at what we have here. We have two pieces of information. One piece of information is this. Cosine is equal to -1/2. Another is this. This tells you where your angle will fall. Okay? So this is 90. This is 180. This is telling us our angle is in this quadrant, quadrant 2. All right? That is important information that you have to figure out before you do anything. Now, okay, let's write down what we have and what we need. We are given cosine. We need sine. So what you have to do now is you have to look for an identity. Find an identity. Okay, where are the identities we have? They're all on the first page. You have to find an identity that relates what you have to what you need, but you shouldn't have anything else in there because there will be two unknowns, right? What you have, so you can use anything from either of those two boxes, right? So there's one that relates what we have and what we need with nothing else. That's the one. We're going to use the Pythagorean identity. Okay? So we're going to use sine squared theta plus cosine squared theta is equal to 1. Okay. So let's see. Sine squared theta plus, what's cosine? Are we -1/2? But we got to square that. Equals 1. Right. We plugged it in. So now sine squared theta plus 1/4 is 1. Minus 1/4 minus 1/4. Sine squared theta is 3/4. Now what do? I have something squared equals something. Take a square root of both sides. When I take a square root of both sides, I got sine of theta is equal to plus or minus, don't forget the plus or minus, √3/2. Okay, now, I can't have two answers. I need one answer. So now, how do I choose which one? Okay, but how do you know what do you use for that? What do you use for that? Huh? Which one? How? Give me a reason, because you're right, but give me walk me through your reason. Right, so remember how we said our angle is in this quadrant? In that quadrant, sine is positive. So I know to take this one, okay? So, good. So now, angle is in quadrant 2, therefore, those 3 dots mean therefore, right? Sine of theta is √3/2. Okay? Right. So, this is the process. We could have, yes, done this using triangles. But again, it's not about the final answer, it's about the what? The process. And here we're learning using identities, right? We don't care what the final answer is. We care about learning the process, right? Because when you go into higher level math, often they will say, okay, sine of theta is this. So show that, right? They'll say cosine of theta is this, blah, blah, blah. Show that sine of theta is root 3 over 2. So now they gave you the answer. Nobody cares about the answer. Get the answer is what we care about. Okay? All right. So given that sine is this, find secant. So first of all, we are now in between 180 and 270 here. Okay, my given and my what I need. So let's find an identity that relates sine to secant. Tell me if there is one. The first one? Wait, which one? This one? So that's cosecant. I want secant. Right? Is there one? No.
You could use the third one here eventually.
Okay. So we could, okay, so it's probably a good idea to use one of these. Okay? We have sine. The first one has sine, but it relates to cosine. Then we take the reciprocal, right? Okay, so we're going to use the first one. So we're going to use sine square theta plus cosine square theta equals 1. And okay, so sine of theta is negative 2 over 7 squared. Okay. So what's this? 4 over 49. Believe it or not, the majority of the questions happen there because people square incorrectly or when they subtract. And these are non-calculator questions, right? Because this is honors math. Okay, so plus cosine square theta is equal to 1. Subtract 4 over 49. Cosine square theta is 1 minus 4 over 49. And we need exact forms, right? No decimals for these. I mean, obviously there's no calculator anyway. So this is going to be how much? So positive 45 over 49. Right? And then we're going to, well, this is cosine squared. Now I want cosine. Take a square root. So cosine is plus or minus root 45 over 7. Okay, raise your hand if you say we take plus for cosine. Raise your hand if you say we take minus for cosine. Minus for cosine because in quadrant 3, cosine is negative. So cosine of theta is equal to negative root 45 over 7. Okay, can root 45 be simplified? Oh, you are so sure about that, huh? That is what do you think? You wanna reconsider that answer? So 45 is what times 5? 9 times 5. So this is negative 3 root 5 over 7. That's great, but not what we're looking for, right? What we really want is secant of theta. So that's negative 7 over 3 root 5. Multiply by root 5 and negative 7 root 5 over 15. Okay? All right. So simplify the radical first, because then you're going to have root 45, then you're going to have to simplify more. So always simplify first, It's better math. Okay, it's like swift. It's more swift. Yeah, for sure. You want to get the final answer for cosine first, then do that extra step. Okay? It's just easier that way. All right. So now, given that sine is this and theta is between these two, find the exact values of the other 5 trigonometric functions of theta. So here, you were given sine, we just needed secant. Now we're given sine, we need to find cosine, tangent, secant, cosecant, cotangent. It's a lot, okay? But we can do it. Okay, so first figure out the quadrant. Who says we're in quadrant 1? Who says we're in quadrant 2? 2 it is. Okay, what identity are we going to use? Huh? First. Sure. Go ahead and use the first, all right? I'm going to race you to it. You ready? You mark? Get to go. Same one that we were using. Okay. Cosine of theta is negative 3 over 5. Fabulous. Okay. So now we have sine and cosine, right? Okay. So let's make a list here. Sine of theta, 4 over 5. Cosine of theta, negative 3 over 5. Okay, now, tangent of theta. Is there an... Okay, so what we have now is sine and cosine. We want tangent. Is there an identity that relates sine, cosine, and tangent? Which one is it? Sine over cosine. Yes, you can. So sine theta over cosine theta, 4 over 5, negative 3 over 5, negative 4 over 3. Okay? You have to show me this. You have to show the work. You have to justify your answer. Then, do we know the rest? Cosecant of theta is the reciprocal, 5 over 4. Secant is the reciprocal. Cotangent is the reciprocal. Okay? So here we go. All right? Huh? Yeah, it's not that bad. It's not that bad. Yeah, it's not that bad at all. The first one is where it's the most time consuming. Yeah. So everything, right, is going to be from here, right? And yes, by the time you take the test, you need to have these, like, we're not going to be given these, right? But do we know everything in the first box? The second one, sine squared plus cosine squared equals 1. I mean, the more you do, the more you learn, right? Okay. All right. Here we go. I have tangent equal to 7 over 2. So let's fix the quadrant first. This should be your first step always. 3 pi over 2 to 2 pi. We're in this quadrant. Okay. You want to do the second Pythagorean identity? The one with the tangent? The first green one, the one with the tangent? Let's do it. Tangent squared plus 1. Tangent squared theta plus 1. Secant squared theta. All right. race you to it. Go. There should be like appropriate music. What's a good background music for doing this? Jeopardy music, right? Yeah, maybe you can. Oh boy. That sounds like okay. No, it's Andrew. Okay, that sounds like wait, there's an instrument. All right, wait, you're distracting me. Okay. Oh, you did beat me. You guys worked together. The whistling distracted me. All right. So we're finding secant, right? So why don't we find secant and stop? Let's make sure. Let me walk around. Let's make sure everybody has the right answer. And we can go from there. All right. Racing you to find the other stuff. All of them. So we now have tangent and we have secant, so you need to find sine, cosine. All right. Okay, thank you. Okay, so these are the more obvious ones, right? The purple is what we already have. These are the more obvious ones. Now, I want to find sine and cosecant. Well, sine and cosine together divide to make tangent. So, why don't we write that out? Never never skimp on the work you show, right? Write everything out. So tangent of theta is sine of theta over cosine of theta. Now, let's substitute what we have. We know 7 over 2 is tangent. We don't know what sine is. We know cosine is 2 over root 53. Okay, here's where we might run into some issues if we're not careful. What do you suggest we do next? Okay, so not that. Okay, the reason is that would have been okay if this was a simple fraction. This is a complex fraction. Why don't we turn it into a simple fraction first? So 7 over 2 is equal to sine of theta times root 53 over 2. Correct? So now what do you think we should multiply by? 2 over root 53. 2 over root 53. Okay? So these go away, and I get sine of theta 7 over root 53. No, Ryan had said multiply by 2 over root 53. Ryan had said multiply by root 53 over 2. Because we're used to multiplying by the reciprocal. But in this case, do you see how we didn't multiply by the reciprocal of this? We multiplied by this entire thing. The reason is we have to multiply by the reciprocal, like by the denominator of this entire fraction, right? The denominator of that complex fraction is 2 over root 53. So listen, my advice to you would be We never like complex fractions. First, write it as a simple fraction, then it'll be more obvious what to do. Okay, so let me write this here. So this is going to be 7 root 53 over 53. The cosecant, I just flip this, root 53 over 7. And now is a good time for some questions. Okay, negative angles say the following. If you have sine of negative theta, the negative comes out. If you have tangent of negative theta, the negative comes out. So you have negative sine theta, negative tangent theta. If you have cosine of negative theta, stays the same. All right? I'm gonna go into the y next time. Okay? I'm gonna go into the y next time. Similarly, look at these. Sine of pi over 2 minus theta, cosine. I know it's weird. We're going to go into y tomorrow. Cosine of pi over 2, sine. Tangent of pi over 2 minus theta, cotangent. So did you ever wonder why it's sine and cosine? How are they related to each other? It's like this. These are the cofunctions that relate them to each other. So what we're going to do today is we're just going to apply these, right? So take a look here. If you're walking down the street and you see tangent pi over 2 minus theta, what is this entire thing equal to? Cotangent theta. If you see cosine of negative theta, what is that equal to? Are you sure? Cosine theta. Okay? So, now, look at this one. I have, for now, we're going to go back to it in a little bit. Theta and cosine of theta. I have secant of theta. What's this? Negative sine of theta. What's the other one? Cosine of theta. So all that will be negative secant theta, sine theta, cosine theta. Okay. Now, we are going to stop here for today, right? So for your homework, no, because look at the identity. The cosine is not negative, right? Okay. So for your homework, I'll tell you exactly which numbers I want you to do.